So I'd like you to have a go at trying one of these problems. I'm going to mix it up just a little bit, but I think you can put it together. I'll give you two standard electrode reactions. So let me give you this one. So zinc, and it should be aqueous, but I'm going to leave that off for now. Plus 2 electrons gives zinc solid. And, I guess I'll put those in, why not? And we've got the standard electrode potential for that is minus 0.76 volts. And then maybe gold 3 plus 3 electrons goes to form gold solid, and it's got an E standard, so an electrode potential of positive 1.5 volts. So can you take this information and figure out what would the cell diagram be for a spontaneous cell built out of these two redox reactions? B, what's the cell voltage going to be? And C, what would the overall chemical equation be? So pause the video and have a go. If you get stuck, kind of unpause it and, hopefully pause it after each one of those three things to see if you can figure it all out. All right, let's try. Okay, so the first thing I think you need to do is decide which reaction is actually going to be the favored one. So they're both reduction, but of course it's not red-red, it's redox, right? You got to have reduction and oxidation. So the more positive voltage is the forward reaction, the less positive is the reverse reaction. So of course one here was positive, one here was negative, so it made it easier, but still we know that the first one, the zinc one, is actually going to go backwards, so that's going to be an oxidation. So where does oxidation take place at? Yeah, that's right, the anode. And the second one is going to be favored to be a reduction. It takes place at the cathode. And remember, when you write these cells out, right, you write the anode before the cathode. On the very far ends, you write the electrode, so the solid. And then we put a line for the phase boundary, so then we're going to have zinc 2 positive. And I guess we should stay under standard conditions until we know how to handle non-standard conditions. There's our salt bridge. Then we've got the gold 3 positive. And at the very end, we've got the electrode. So we need the solid, gold to be the electrode at the far side. So that's the first part to it. So if you got that right, well done. Pause the video and see if you can calculate the cell voltage next. All right, so the cell voltage, so E cell is E cathode minus E anode. If you like, it's E right-hand side minus E left-hand side. And we can look those up. So the cathode is the right-hand side, so that's positive 1.5 volts. And subtract away from that the anode, the left-hand side, so that is minus 0.76 volts. And if you're like, whoa, hold on a second, because I flipped that one, don't I change the voltage? You fall into the trap. No, you don't. So why don't you? Well, that negative there essentially handles that sign change for you. So don't ever get cute and write the negative and turn that around. Otherwise, you're going to have a whole world of hurt. So all right, that's going to be quite positive, isn't it? So if I add those two together, it's going to be positive 2.26 volts. So what does that mean? That means that it is spontaneous as written, so we didn't get it backwards. Now, what about the cell reaction? Well, I'll have to flip to another slide to have this one, but see if you can follow along with me. So I write out the reactions the way they're taking place. So the gold 3 is picking up 3 electrons and being reduced to gold. And let me see, the zinc one's going backwards, isn't it? So the zinc is actually losing 2 electrons, okay, and becoming oxidized at the anode. And if we add those together, right, we'll get an extra electron on the left-hand side. So we've got to, say, multiply by 2 and by 3. That way we got a common factor of 6 electrons on each side. So that gives us, what, 2 gold 3s plus 3 zincs. I suppose I should put the state symbols in for completeness. And it's a 6 electron transfer. I'll just write that over the arrow just for fun. And it's going to 2 gold solids and 3 zinc 2 ions. And just to double check its balance, we got 2 golds, 3 zincs, 3 zincs, 6 positive charge there, 3 times 2, 6 positive charge there. So it is a balanced equation. So that's the very last part of the puzzle. Did you get it all? Hey, good job.